So wonderful. Good afternoon, dear LinkedIn Community Composites Lounge members. I'm here at the ECCA, the European Composites Circular Alliance or Circular Composites Alliance. And together with me is now Malcolm Forsyth out of the UK. Thanks for being part of my show.
I'm very happy to be part of your show. I've watched it a number of times. So it's nice to take part.
Now it's great. Now it's your turn. At Advanced Engineering last month in Birmingham at the NSC, I had David Bailey already on the camera and also your new president, Faye Smith, right? So now let's talk about sustainability. But before we come to sustainability, Malcolm, could you introduce yourself to our community? I know many people know you already because you are really one of the most active, most engaged people in the composites ecosystem. But shortly, who is Malcolm and what fascinates you with composites?
My name is Malcolm Forsyth. I'm Sustainability Manager at Composites UK. I've been involved in the composites sector for over 25 years. I've been involved with Composites UK for 5 years now as a Sustainability Manager. What fascinates me about composites, I think it's the sheer range of things that you can make with composite materials. It really is, an extraordinary collection of markets, applications and the like. And what engages me about sustainability is I'm a great lover of nature. And I believe that as humanity and as an industry, we need to live in better harmony with nature, with less impact. And sustainability is, as the word says, about having a basis that allows us to live indefinitely as an industry, not as people, but as an industry, without an ongoing negative impact. So,
be honest, there must be a favorite industry, a favorite vertical. Which one is it?
Well, that's difficult, really.
Is it? Okay.
My previous involvement in composites meant I was very involved with the marine industry. So I do kind of think of that industry a lot, and I like the products. They're very functional and often very beautiful at the same time. I like playing paddle tennis. So when I pick up my paddle racket, I think this is a composite product.
Yeah, here we go. Now we got it. The sporting goods industry. Yeah. So let me softly jump into sustainability. Now, sustainability is a strong word, a very comprehensive word. Let's define sustainability in terms of composites. You are now the sustainability manager, but for our community who may have still difficulties to relate sustainability to composites, what would we understand in sustainability terms?
So for me, there are two big elements of sustainability. One is decarbonisation. I think most people globally recognise that there is a challenge from an increasing concentration of CO2 in the atmosphere that's driving climate change effects of different sorts. So we need to do something about that, and we need to stop putting carbon dioxide into the atmosphere. So we need to find ways to decarbonise composite products, the manufacturing of composite products, use of products that we've got composites in. So decarbonisation is one big part of sustainability. But the other big part, and that's really what we're primarily talking about here today in Brussels, is circularity. At the moment, most composite manufacturing supply chains are quite linear. We dig raw materials out of the earth, typically. We refine them, we make parts from them, they get put into applications, they have a life. Sometimes it's a few years, sometimes it's many tens of years. But they have a life and they reach an end of life point. And then what do we do with them? And the truth is today, most go either into a hole in the ground or they go into an incinerator. And that is not a good use of a material which has got so much value left in it, which could be reused or repurposed or recycled a number of times. So as an industry, we need to become more circular, just as all of human activity needs to become more circular. We've got to align with that, and we have a big opportunity to do that.
There was today one of the working group members, it was the aerospace group, said end of service.
Yes.
Now, why do we now divide between end of life and end of service? I find that distinction very clever and very smart.
And it's a very important distinction because composite materials, in many cases, are almost indefinitely alive. You know, the properties are so durable that they will last hundreds of years, and we're now really beginning to understand that. But actually, maybe it's a feature of our society. Most of the products they go into reach an end of service point. People either don't want them anymore, or they are replaced by a more modern version. So we do need to make this distinction between end of life, i.e. when the properties are no longer there, and end of service, which is when the application that the composites are used in has reached some point where the owner of it no longer wants to have it. And it's important because composite end of life is much longer than typical end of service. You know, if you have a car, most cars probably last 15 to 20 years. The composite part in them will still have the properties it had when it was put in the car in the first place. So can we take that part and can we make it into a new composite part, or can we recover the raw materials, the fibers, the resins, so that they can then be made into new parts? That's where this distinction is very important for composites, because the end of life point is much longer than the end of service point, the realistic end of service point. Let's dive a bit deeper into the ingredients of a composite. Like you said, now the resins, the fibers, the textiles. Now, my observation is there are a few startups now emerging that either they recoup the resins with a new type of solvents, or they are recouping the fibers with chemicals or with heat treatment. Where do you see this industry going? Is that already foreseeable, or would you say, okay, we are still in a trial and error phase right now? Well, the first thing I would say is let's remember the waste hierarchy. That actually what we want to be doing is, first of all, reducing the amount of raw materials that we use in the first place. Then we want to be finding ways to maintain them, extend their working life as long as possible. Then we want to be looking at ways in which we can keep the properties of the composites, which is the strength and the lightweight nature of it, hold on to that property, but make it into a new product, which has another 20, 30 years of life. And recycling is really the very end of the process, because we have to put energy and other materials in to enable recycling. And anybody who's made a composite part will know that it's very strong and it's very durable. So it's hard to separate the resin and the fiber. So we only want to do that really as the last resort. But there are now a number of ways we can do that, using both thermal methods, where we put heat in, that can cause the resin fraction and the fiber fraction to separate, or using chemicals. It might be in a solvent process, or using steam. There's a process called pyrolysis, where using water as the solvent, but under temperature and pressure conditions, it can cause the fibers and the resin to be separable, and you can recover the fibers and you can recover the resins. And these processes are all maturing all the time now. Many are commercial. Some are at significant scale. Some are still in that kind of crucial piloting and development phase. But we already have many industrial processes for recovering composites, recycling composites, and we need to see those growing and developing. Then it's more about economics. The technology's there. We need the economics. We need more market demand to grow that business. And we know that with scale comes economic efficiency, lower costs, more profitability, more viability. So,
Malcolm, the other day I saw a Formula E racing car. Now that racing car consists of, 100 carbon composites parts, but there were also some biofiber parts inside there. Now, they would promise and claim that each part can be recycled.
Yep.
Now, given the fact that this has reached a standard operation procedure, so you got SOPs for this, so this can be easily applied in a process. Why is then the automotive industry, now I'm talking from the German lens by the way, why is the German automotive industry then still reluctant? Or maybe is it worldwide? I have no idea. I'm just overlooking the German market.
No, it's not just Germany.
Yeah. So why is it then that the automotive industry is so reluctant? And of course, what would be then your recommendation to them?
Well, I think there's a difference of scale here, isn't there? And, Formula E cars, Formula One cars are made in relatively small numbers, and they've got very particular, very high performance requirements.
Actually, they are spec'd by parts, and there's only very few parts which are flexible to develop. Yeah. So they're spec'd. Yeah.
So we're talking about two different markets. Whereas if you like, the main automotive sector, they want to produce hundreds of thousands or millions of vehicles, and they want to be very standardized, and they want to be a very resilient operation. So they need a very robust, resilient supply chain, and they need to be confident in the quality of raw materials coming in. And I think that's one of the reasons why they're still a little reluctant, because the supply chain for recycled materials is still maturing. It's not at the same scale necessarily as the automotive producers want to operate at. So there's a bit of a disconnect, and we need to get the automotive producers to help by starting to work with the maturing recycling supply chain to start to think about where can we put the products into parts in the car, because we need that demand coming through from the bigger players to grow the recycling supply chain. It's a bit of a chicken and egg situation. Which one's going to move first? But we need both, and we need to be working in the smaller applications while we get the bigger ones engaged. And that'd be my appeal to the automotive sector is, can you identify one application which you could easily incorporate a recycled material in? Pick one that's got, good, robust supply chain and consistency of product. Start with one, start making it happen. And as you do that, then you'll say, okay, now we can do a second one, and then we can do a third one. Don't try and make the whole car from at one go out of recycled materials. Just start converting parts where it's practical, where it's technically possible, and where the economics are acceptable. And that's another challenge, because sometimes it's difficult for recycled material to match the price of virgin material. It's possible with carbon fiber. It's less easy with glass fiber. So, don't be unrealistic with your expectations. And maybe there are applications where a small extra cost can be absorbed. I'm not asking, for big premiums to be absorbed, but maybe a small premium can be absorbed, and it helps to get the chain moving.
So this is a very practical approach. It's a really good idea to start small, learn with it, with the small parts, maybe not the high volume part. Take a model that is probably a motorsport, performance car, high performance car, learn with it. How do we connect you with stories within the composites and sustainable materials industry? We are on the ground to find the facts. We examine big, innovative ideas. We let diverse perspectives on technology and sustainability emerge and ignite conversations that matter most to bring you the composites and sustainable materials world. Stay informed, stay connected, stay inspired. From our online studios in Germany, covering events and corporates from France, Italy, UK, Central Europe, and many more European regions. Join us for creating sustainable value.
With Composites 360 on Tour, Composites Lounge engineering talks, and Composites Lounge end-user panels hosted by Ilkay Özkisaoglu. Weekly on LinkedIn, YouTube, and your preferred podcasts.
I have a theory, Malcolm. If I look at the automotive industry, now let's zoom in. We've talked really the bigger picture now, but let's get really to the designer. So there is a designer, he's on the drawing board, whatever, pro engineer, CATIA, whatever he has as a software. And the old part is a metal part. Now, my theory is that basically there is no reflection on it. Could I now replace that metal part by a lightweight and mechanically strong composite part? And then should I replace it with a thermoplast or a thermoset part, or even, I don't know, other resins or other matrices? So I think the school of thought here is this worked all the time, and I will not risk to change to other materials. Now, this designer probably has to get an approval from his leadership or from his management to change the concept from A, material metal, to B, to composites. Now, the boss may even not be aware that he's working on such a project, but the designer makes it easy for himself and just continues the metal part. What would you say to this designer to convince him otherwise, to give it a try?
Okay, well, first of all, what are the benefits composites are going to bring? And one of them is, in most cases, it'll lightweight the part.
Yeah.
Now, in the automotive industry, lightweighting is a big theme because of the need to reduce tailpipe emissions from the vehicle, if it's a petrol or a diesel vehicle. So, one of the ways that is being worked on is make the car lighter and lighter, so it will generate less emissions. And there's a legislation requirement to do that. So, the pressure's really on. So that's already happening. People are saying we need to look at everything because we need to take 10%, 20% or more out of the weight of the vehicle so that we can reach the requirements for the tailpipe emissions. So there's already pressure to change, and you need that. Yeah. Then you need to think about benefits. People make a change when they can see some clearly quantified benefits. Now, clearly, we know lightweighting and emission reduction is one, and that will have cost benefits, but there may be others as well. Durability. Composite parts don't corrode. They don't rust in the way that some metals do. So there's a benefit. Less maintenance. Actually, longer term value.
Actually, if I may say that, in my previous corporate life, we won a contract with a premium car manufacturer out of Germany, Ingolstadt. I cannot mention now the name, but Ingolstadt, I think, is clear. So we had a part in the underbody out of metal. And the question was, how can we, replace the metal part that is corroding because the heat was cycling all the time. It was close to the exhaust system. And then we found something with a technical textile with an aluminum coating on it. And actually, they did the cycle runs, and it didn't really change any color. And the part was more expensive than the part previously, and we are talking now really 44 to 45%, which is really significant. That's on the part.
Yep.
And the designers then really said they want this part because it may happen that the car owner will put that car up and sees that yellowish corroded part, and that is not according their reputation and image. So composites are also a visual design factor, isn't it?
They are. And obviously people incorporate that, particularly maybe in some of the internal styling. Many people like the sort of textile, the carbon fiber textile finish that you can get. It looks very high tech. It looks very smart and elegant. So yes, there's an aesthetic element to it. I think it's all about understanding what customers want. What's the value of that? Because in the end, it is about economics. You will get some applications where just being a more natural part or a part with better environmental characteristics alone will justify some premium. But in most cases, and particularly at bigger volumes, there needs to be a clear economic benefit. So you've got to break it down as to what is that economic benefit. And it could be durability. It could be about you don't need to replace it. You don't need to paint it. You don't need to maintain it. It might be about the tax you pay on tailpipe emissions. So if we can accept a slightly higher price for the part, because we save more than that with the saving on any taxation we pay on tailpipe emissions. So, and with composites, we always say to people, you need to think about the whole life cycle of the part, because that's where composites often is the winner, because the full life cycle cost, if you like, of the part is less with composites than it is with other materials. So think the whole life cycle, and then you might see more economic benefits that will further strengthen the argument for using composites.
Yeah. So I'm just checking my smartphone here, dear community, because the audio is now tracked by the smartphone this time. So we have already 19 minutes, and I could go on and on with you. So let's. So this will be 2 episodes anyway. My final point with you is thanks for the sustainability part, and we know about the UK thanks to David and Faye already. Now we are here at the General Assembly of the European
Circular Composites Alliance.
Exactly. Yeah. I was sent to say it the other way around, but it's a Circular Composites Alliance. And why would Composites UK support this alliance?
There's a very good question. And obviously the UK is not politically part of Europe anymore, but geographically...
Interesting you say that. I would not be brave enough to say that.
The UK is part of Europe.
Yeah.
And the challenge of creating more circularity with composites is a global one. And what we don't want is each sort of little country or region all developing their own solutions, because that will mean a lot of repetition, a lot of overlap, a lot of wasted effort. So we're here because we want to support the whole European industry. We want to play a full part in that. Many of our members export products into the European Union, and many of them get their raw materials from the European Union. So there's already a lot of cross, trading between the two blocks. And as I said, the problem of composite waste doesn't really recognize national borders. And we need to be working in a way that will allow as easy movement as possible of composite waste from country to country. It will not make sense for every country to have its own little circular composite systems, to be necessarily having a recycling plant in every country. That probably isn't going to be the most economic way. The most economic way is going to be to have maybe some slightly larger hubs where bigger quantities of material are processed. And some of those hubs might well be in the UK. Some of them will be in Europe. And I would want to see movement of waste and recycled products going the 2 different ways. So we need to make sure that the UK and Europe are working well together, sharing ideas, sharing initiatives, contributing to each other. Successes here in Europe with legislators, we will look to replicate in the UK with the UK government, and vice versa. If we manage to persuade the UK government to implement a regulation that we think is going to strengthen and help recycling, then I would want to share that with my European colleagues, and they will hopefully get something similar from the European Commission here, as the key legislator or regulator. So,
why should you invent the wheel 2 times? So
exactly,
just invent it once. Like one example is during the Birmingham show, we talked about Fraunhofer Institute in Germany. Now you got Catapult in the UK, which is a similar setup. So the blueprint is there, and you just apply it, and it is to the benefit of all the countries. Malcolm,
another example is the National Composite Centre, or the NCC,
which is now AMRC.
No, it's still NCC.
Okay,
but there's representatives from the NCC here.
Oh, okay.
Because they have got knowledge and expertise that are going to be valuable, and they will learn from. There's probably representatives of other institutes and research institutes in this audience from Europe. So this is a way of facilitating exchange, valuable exchange within the composites sector across all of Europe, not just the political parts, for the benefit of the whole industry.
Excellent. Malcolm, short outlook, JEC World 2026.
Yep.
How far are you with your preparations for JEC World 2026?
I would say our preparations are going well. We will be running the UK Pavilion again.
Yes.
We already have most of the space booked, which is good. So if there's any UK companies thinking, do I want to be at JEC World? Well, there's still space on the UK Pavilion, but it's selling fast. So don't wait too long.
Don't wait too long and be fast. And it's an easy entry, right? So you take most of the work. The design work is done by you guys.
People they can buy a 1 square meter pod. They can buy a bigger corner stand.
Yeah.
So we do the work.
That's great.
They pay us to provide that service for them. And we're also getting ready now for the different meetings and the like. So I'm going to be chairing a forum session at the JEC on composite circularity. Look out for that, 12 o'clock on Wednesday the 11th.
So it's the second day of JEC.
Second day of JEC. Yeah. And there'll be many other meetings that will happen. There'll be an ECCA meeting, I'm sure, will happen at the JEC. Absolutely. Just because it's a practical thing. All the key people are there, so let's get them together in person to work on the ongoing challenge. So I'm looking forward to 3 good days in Paris. I know I'll see you there, and hopefully see many of your audience for Composites Lounge.
Yes. So the Composites Lounge community is very vibrant, and they will be for sure there. So make sure everyone, like Malcolm said, also stop by the Composites UK pavilion, which is always also a large one compared to other places where you also exhibit. Malcolm, it was really a pleasure talking to you. We went very deep into sustainability. I have to tell you that I've never been that deep into sustainability and never been so practical in it. So thank you very much. It really shows your expertise, and I'm really proud.
Good. It's been a pleasure as ever, and I hope it's been interesting and it's helpful for the audience, and they can use it to take their own sustainability journey forward, whether it's decarbonising or making their business more circular. That's what it's all about.
Okay, I think it's now time to go back to the working groups.
We better
because
go back to our working groups.
Okay, bye-bye.
Thank you very much. Bye.